Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to solve problems involving compound interest. Now, there's two formulas for compound interest. You can see them, here, and I'm going to explain the difference in a moment. So let's talk about this first one. This is the general compound interest formula. Now, the idea here is that when you put money into an account, at some point, right, the bank or whatever it is pays you interest. In other words, they're giving you money to hold on to your money so that they can use it, honestly, for higher returning investments. Now, the idea, though, is they'll promise you some sort of annual interest rate, which we'll use as R. Okay, the amount of money that you invest is P. Now, A is how much money you'll have after T years. Important to note that T always refers to the number of years that you are investing. And N is how often interest is compounded, the number of times per year. So if you were to, say, have your interest compounding monthly, that means that you would earn interest every 12 months. And what would happen basically is, let's say you just to make the calculation easier, let's suppose the bank promised you a 12% interest rate compounded monthly. What that would mean is every month you would earn 1% interest, and then over the course of 12 months, you'd get 12%, or 1% applied 12 times. Now, with compound interest, you earn interest on the amount of money you've already earned in interest. So, in other words, that first month, you'd earn 1% of your money, and then the next month, you'd earn 1% on the original amount you invested, plus that 1% you'd earn in the previous month. Now, a lot of times with banks, you can have your interest compounded monthly, so once a month. Quarterly, that would be 4 times per year. Semi-annually would be, say, twice per year. Yearly would just be once per year. Okay, you could have it be weekly, daily, whatever. Now, as we compound our interest more and more and more, okay, so say we go from like weekly to daily, you could compound hourly, minutely, you could compound every second. If your money is always compounding, so every moment in time you're earning interest, we call that continuously compounded interest. And basically the idea here is as n gets really large, this formula is going to become this one where it's a equals p e to the rt. This e, right, is the Euler's number. So this is a natural exponential function. Okay. And so if your interest is compounded continuously, you use this formula instead. The p and the a are the same. The r is the same. T is still the time in years. Example 1. Suppose that $50,000 is invested with 3% interest, compounded monthly. Determine the amount in the account at the end of 10 years, round to the nearest cent. Now, it's very important that when you start writing this stuff down, your principal, so the amount you're investing, is $50,000. Okay. Your interest rate, now it's important you don't write down R equals 3. Whenever you have a percentage and you want to do a math problem, you always have to convert the percentage to a decimal. So you take 3 and you divide it by 100. So that just means moving the decimal place 2 places to the left. So you get 0.03 and not 3%. Okay, so always, for any math problem, you always will convert that percentage to a decimal. Now it says compounded monthly, so that means we have n equals 12. Okay, so RA is just going to be 50,000 times 1 plus r over n, so 0.03 over 12, and then it's to the nt power. So n is 12. Okay, we wanted 10 years. Sorry, I didn't write down t equals. You can write down t equals 10 over here. Okay, so if I just simplify this a little bit, okay, you're going to get over here 1.0025 to the 120th power. And if you work that out and you round it to the nearest cent, you should get $67,467.68. Okay, very important when you're doing a real world problem and the numbers aren't pretty and you have to do some rounding, you always want to round at the end, never round in the middle of the problem. Example 2 is a continuously compounded interest problem. So notice again, it says continuously here. So that means we use the p equals e to a equals p e to the rt. All right, so our principal here is $28,000. Okay, our 5% interest. So again, divide 5.5 by 100. So you get 0.055, and our t is 15 years. There's no n here, okay, because we're compounded continuously. So our amount we earn is going to be p times the exponential of 0.055 times 15. So that will be 28,000 times e to the 0.825. And if you work that out and you round to the nearest cent, you should get $63,892.66. Example 3. If $10,000 is invested in an account earning 4.75% interest compounded continuously, determine how long it will take the money to grow to double. Round to the nearest tenth of a year. Okay, so in this problem, we actually have to solve an exponential equation. So that's another video we did. Go review that if you need to. Now, our principal is $10,000. Our interest rate is 4.75. If we divide that by 100 to convert it to a decimal, we get 0.0475. Now, we do not know how long we're going to be investing, so we have to find t. But we're interested in how long will it take for our money to double, which is the same as saying, when will the amount we have be equal to $20,000? Okay, so if we set up this equation, we get 20,000 equals 10,000 times e to the 0.0475 t. And now all we have to do is solve this exponential equation. So we divide both sides by 10,000. And we end up with 2 equals e to the 0.0475 t. Notice it didn't really matter what we started with. If we're just want to know how long will it take to double, our starting money doesn't matter for this, right? T will be the same no matter what, as long as we're interested in how long it takes to double. Okay, so now we want to solve this equation. So we have, different bases for our exponential expressions on both sides. So what we'll do is we'll take the natural log of both sides. So take natural log of this, natural log of this. On the left-hand side, we get natural log of 2, which is some number. On the right-hand side, the natural log cancels out the exponential function, and we just get 0.0475t. And then we can just divide both sides by 0.0475. And so t is just going to be natural log of 2, which is a number, divided by 0.0475. And if you plug that into your calculator and you round it to the nearest tenth, you should get that t is 14.6 years. Example 4. You have $25,000 to invest. What interest rate compounded quarterly would be necessary to have $65,000 in the account in 20 years? Round to the nearest hundredth of a percent. Now, if this was continuously compounded interest, and it's not, it says compounded quarterly, it would be a similar problem to the one we just did. But because it's not, it's going to end up being more of solving a polynomial equation. So our principal here is $25,000. Our interest rate, we want to find the interest rate, right, R. Our amount we're going to have at the end of our investment should be $65,000. We're compounding quarterly, so that means n is 4. And finally, our time is 20 years. So if we plug everything in, we get the following equation. 65,000 equals 25,000 times 1 plus the interest rate, r over n is 4, to the 4 times 20, so n times t, right? So all we really have to do here is just divide both sides by 25,000. Okay, if you do that, you're going to get 2.6 on the left-hand side, just exactly 2.6. And you get 1 plus r over 4 to the 80th power. And so really, to solve this, all you got to do is just take the 80th root of both sides, right? Kind of weird, or you can take to the 80th power, but really it's the 80th root is what we're doing here. Okay, and if you do that, you get the 80th root of 2.6 equals 1 plus r over 4. Now my suggestion is just find the 80th root of 2.6 at the end of the problem. So if we solve for r, we just subtract 1 from both sides and then multiply by 4. What you're going to get is you're going to get r is 4 times the 80th root of 2.6 minus 1. Okay, and if you round that to the nearest, so this is tricky, the nearest 100th of a percent basically means round it to the 10,000th place. So it's going to be 0.0481 if you do that. And so your interest rate is 4.81%. And that's it for compound interest problems. A lot of the difficulty here is mostly just, one, understanding exponent rules and exponential equations, and two, not rounding too early. Sometimes if you round too early, your problem can be off by quite a bit at the end. Rounding error in these kinds of problems with exponents can end up being, off by a lot. So my suggestion is always round at the end. All right, until next time, have fun.